I'm Jim Clark in the Nicholas School of the Environment and the Department of Statistical Science at Duke University. I'm also part of the four-year program here in France, Emmanuel Macron's Make Our Planet Great Again.
I'm Jennifer Swenson, and I specialize in remote sensing imagery. We are working together to model species distributions in their response to climate change. Our project, PBGJAM, is able to integrate disparate data sources from the field, geographic data on climate and land cover, along with this very rich database of remotely sensed data. JIM is really the brain behind the GJAM model.
So GJAM is an acronym for Generalized Joint Attribute Modeling, and PB is predicting biodiversity. This model was put together to address the problem of communities that are changing rather than species changing independently. Most of the problems that we encounter as ecologists are not how does one species change, but how do multiple species change that are interacting with each other. There's no way to sort of take independently fitted models and talk about uncertainty in the community.
For example, where a tree or a plant is going to be directly affected by changes in temperature and precipitation, the species that depend on those plants are also affected.
Species that are responding to climate change are also responding to other species that are also responding to climate change. So in other words, they're interacting, they're a system.
Climate change is also affecting the phenology of events, and phenology just means the timing of, the timing of spring. When do leaves come out? When does flowering happen and fruits are produced? And so especially hard hit could be migrating species arriving at the same time of year, but actually late because springs are becoming earlier and earlier now.
We've seen extreme effects of climate already in many ecosystems. To understand dynamics, you have to observe the same locations repeatedly through time, and that sort of information is very hard to come by.
We based a lot of the predictions on NEON data sites. NEON is the National Ecological Observatory Network. The NEON sites have identified these unique undisturbed ecosystems across the US, and within those sites they have plots designed to sample trees, the beetles and the ticks and plants and the small mammals. They monitor the forest structure through lasers. We can actually identify certain spectral traits of different tree species, nitrogen content in the leaves and potassium content. They are the most detailed information that we can get from ecosystems.
I don't think what we're after are models that we think are going to give us a good prediction. There's an 80% chance of rain tomorrow and it rains. I don't think that's the sort of thing that we should be focused on, because these transitions are going to be complicated. We shouldn't expect to be able to predict them very well, but we should be using efforts like this to try to better understand them.
We designed the web mapper to be accessible to scientists, but also to land managers. You can download the maps. You can even run your own GJAM model if you want with your own data.
We hope that it'll allow us to put together the changes that have been happening together with the predictions of what will happen in a format that could be useful both for scientists and decision makers.